All right, so in terms of motion in one dimension, uh, in Grade 10 we must know a set of definitions, right? We need to know these, these definitions like number one, you need to know what is a vector, displacement, you need to know how to define them, right? And then distance, um, velocity, acceleration. I can say these are the most important definitions that you need to know, right? Displacement, we know that is the change in position in space, the change of position in space. Distance is the total path length covered. Velocity is the rate of change of displacement or the rate of change of position per unit time. Oh, and also speed. Speed, the distance covered per unit time. Acceleration, the rate of change of velocity. And then a vector, a single force having the same effect as all other forces combined. So for example, for 2.1 here, you see they want you to define a vector, so we need to know those definitions. So we have a motorbike here, right? We have a motorbike which is producing a driving force of 500 newtons as the bike and rider move west, right? When the rider applies the brakes, a frictional force acts on the wheels, slows down the motorbike and the rider. So calculate the resultant force acting on the motorbike and rider. Treat the rider and the biker as a single object. Okay, no. Okay, that one relates to your vectors. Okay, the addition of vectors. So for 2.2, right, what you do is that for vectors especially, to get the resultant force, we call that F net. Sometimes it can also be called F resultant, but we usually use F net. Then the forces that are acting there, the first force is the driving force. It's usually called an applied force, okay? And then the second force is a frictional force, so we usually just put F there, right? Now we have to choose our direction. So we can choose west to be positive, or we can choose east to be positive. So for this example, since they already talked about west, we're going to say west is positive. Then from there, we're going to say our net force will be F applied, which is the driving force, is 500, and it's acting in the west. That's why I'm putting it as positive. And then friction always acts in the opposite direction, and that friction is negative 150. Okay, so from there you're going to get your answer as I think 350 newtons. There is the F net. Now this means 350 newtons westwards because that answer is positive. So it's just a way of adding forces. Remember, just use that formula. F net is equal to Fa plus and it's equal to the forces that are on the object, right? But our main issue was here calculating, using the equations of motion. Now these equations of motion, remember there are 4 of them, so I'm gonna try and just write them here, of which we're going to try and then use them, right? So we have Vf is equal to Vi plus a change in time, right? Then we have Vf squared is equals to Vi squared plus 2a change in x. Then we have change in x is equal to Vi change in t plus half a change in t squared, and then change in x is equal to Vi plus Vf divided by 2 multiplied by change in time. Then from there we can then say they said the rider travels 160 kilometers westwards against the wind in a time of 2 hours. The rider immediately turns around and rides back to the starting point in a time of 1,67 hours, this time with the wind. Write down the total displacement for the entire journey. What would be the displacement there?
I think it's so is it fine if I calculate
Mm, well, we need to understand that, well, the displacement there is just 0, right? We can say 0 kilometers. Yes. Why? This is because if you go somewhere, if you can remember when you're talking about distance and displacement, if you go somewhere, right, and then you return to the same position, your displacement is 0. It's like you didn't move. Okay.
yes, sir.
Yeah, so hence the displacement is 0. So whenever someone travels somewhere, or rather moves a certain distance and then moves back to or returns back to the original position, the displacement is 0.
Okay.
Great. And then calculate the average speed of the motorbike for the entire journey in kilometers per hour. The average speed of the motorbike for the entire journey. Now, the key word there is speed, okay? Calculating average speed, remember that we use the formula v is equal to change in x over change in time. And let's remember that because it is speed and not velocity, here we would be talking about distance, okay, because we're talking about speed. So now what is the distance that he traveled, right? Maybe in terms of graphically, so that we can understand this, right, we can say the rider traveled 160 kilometer westwards. So here is a rider here, 160 kilometers westwards, and then in a matter of change in time is what is 2 hours. And then the rider then immediately turns around and goes this side, right? We know that he's going to travel the very same 160 kilometers because he returned to the original position, but this time the time was 1,67 hours. The time that he took to return back is lesser as compared to the time he took to go, because as he was going back, they said that he was going with the wind, so the wind was also assisting him. Right. So in terms of velocity and average speed, we use the whole distance. We say 160 kilometer plus 160 kilometer, right? 160 plus 160. And then how long? How long? They said for the entire journey. How long did it take for the entire journey? That would be 3,67 hours, right?
Yes, sir.
The entire journey, 3,67 hours. So what would be his speed?
Speed would be, let's see, it's going to be 87,19 kilometers per hour, the average speed.
87,19 kilometers per hour. Ne? Great stuff, great stuff. So that's how we would get the speed there. Speed, you consider the distance, okay? By the way, if I were to say calculate his velocity for the entire journey, how would we calculate that? Because remember, this is speed. If we were to calculate the velocity,
Yes, sir.
right, so in terms of velocity, you would still use the symbol v, right, and then you say change in x over change in time. However, you must know that here it is the displacement, It's not distance, okay?
Yes, sir.
For
Okay, sir.
velocity, yeah.
How do you differentiate between the two formulas, the first one you did and the one that you wrote right now? Because they both have changing x, they both have changing t, and they both have
Yeah, the formulas are the same, but when you must know what are you calculating, or when in terms of are you calculating speed or velocity. Remember, you're the one who is supposed to write the formula, right?
yes, sir.
So when you write it with an intention to say I'm calculating velocity or I'm calculating speed, isn't it?
Yes, sir.
Yeah, so the only difference is that when you are calculating speed, here you are going to consider the distance. But here, when you are calculating velocity, you are going to consider the displacement of the object.
Oh, okay, sir. Yes, sir.
Yes, so just keep that one in mind. So the displacement is 0, and then we said the time was 3,67. So therefore, his velocity is 0 meters per second, which makes sense because he has returned to his original position, so his velocity is 0. You see?
Okay.
Yes, great stuff. Then now for 2.5, they say now, calculate the magnitude of the actual velocity of the motorbike in kilometers. The wind blows at a constant speed of 8 kilometers per hour eastwards. Calculate the magnitude of the actual velocity of the motorbike. In other words, if there is no wind. If there is no wind. So they are trying to say that calculate the actual velocity if there is no wind, meaning that looking at his journey returning back, right? Remember, he took less amount of hours, right?
Yes, sir.
Yeah, he took less amount of hours because of what do you call the wind blowing there. So we want the actual velocity with if there is no wind. Well, it's fine. To get the actual velocity, we're still going to consider the displacement. Then we say over time. Now his displacement there is going to be it's going to be, let's see, yeah, it's going to be 160, which is 160 kilometer divided by, now he's supposed to take 2 hours, I get, because that is when there is no wind. He was supposed to take 2 hours, so it means we say divided by 2 there, so that should give us 80.
Sir,
Yeah,
so if it's 2 hours, don't you like simplify to make it 120 minutes?
in this case we don't do that because they said in kilometers per hour. Yes,
Oh,
yes. In normal circumstances, we do change to, we do use meters. We do use what we call. We do use seconds, right? Meters and seconds. But now it's just that they specifically told us. You see, they specifically said that we must use those ones.
yes, sir.
Great. So always ensure that you check what you call. Always make sure that you check the question, what it is looking for there.
Okay, yes, sir. Yes,
Are we okay there?
yes, sir. Yes, sir.
That is fine. That is fine. So let's see. So 2.4 we did say 87 comma 19, ne?
Yes, sir.
And then let's see kilometers per hour. So here we said we calculated the velocity he would have. This is the velocity that he would have been traveling at if there was no wind, isn't it?
Yes, sir.
However, we must remember that let's see. So in fact, let's say this is the velocity for him to travel from this position there, A to B, right? But now they told us that the wind is blowing at 8 kilometers per hour, which means that this velocity there is consisting of the velocity of the bike, ne? Velocity of the bike minus that of the wind, isn't it?
Yes, sir.
Is the velocity of the bike minus that of the wind. So which means that remember that the wind is blowing at 8. Therefore, it means that the bike on its own is actually traveling at a speed of 88 kilometers per hour there. 88 kilometers per hour there. Okay, because you must understand that this 80 kilometers is consisting of both of them, to say to travel from A to B. Now if we can remove the velocity of the wind, we can then get the velocity of the bike. All right,
Yes, sir.
great stuff, great stuff. So yeah, that is how we would do that there, right? So maybe let's see just maybe another question to give us an understanding. This one we once did it, but we were talking about displacement only at that time, I remember, right? So now they say a baby leaves a bowl of food on the floor and crawls westwards to fetch a toy that is here. At the same time, a dog walks eastwards towards the baby. It takes the baby 30 seconds, right? Now you must always decode what you are given, that is time there. It takes the baby 30 seconds to reach the toy. So here we can put that the change in time is 30 seconds for the baby. Now we did 2.1 and 2.2. This time we'll say 2.3. Calculate the average velocity of the baby. For 2.3, we want the velocity of the baby. Well, we know that v is equal to change in x over change in time. Now we know the displacement of the baby, right? Remember that when the baby reaches the toy, right, the baby is traveling to the west, and the baby will be 5 meters from where he or she started. So we can say 5, and then the time is what? The time is 30. So therefore we are going to get that is how much there. 5 divided by 30.
So isn't it 1/6?
1/6. So 1/6 give us what?
1/6 gives us 0.17.
0 point
0.17, yeah. 0.17.
perfect. But we must include direction because it's a vector, so we can say west. That is the speed of the baby there, the velocity of the baby, ne?
Yes.
2.4. If the average speed of the dog is twice that of the baby, calculate how long it will take the dog to reach the football from the moment the dog started moving. So now the speed of the dog is actually twice that of the baby, right? So therefore we know that the velocity for the dog is 0.17 multiplied by 2. It gives you what? 0.34 meters per second. Now they're saying calculate how long. If they want how long, it means they're looking for change in time. And then they say it would take the dog to reach the food bowl from the moment the dog started the dog started moving. So now the food bowl is around 12 meters away from the dog. So it means our change in x is going to be 12, and it's distance because now we are talking about speed, right? We're talking about speed. So we say v is equal to change in x over change in time. The velocity is 0.34. The change in x is how much? Is 12, and then we're looking for the change in time. Then from there we know we can what can we do there? We can cross multiply. We have 12 is equal to 0.34 change in time divided by 0.34. So what do we get? How long does the dog take?
The dog takes 35,29.
35.
Yes, sir.
35,29 seconds. Great stuff. Great. So do you see how we use that formula there?
Yes, sir.
Yeah, speed, velocity, that's the formula that we are definitely going to be using there. And it looks at, if you're looking at velocity, then it's displacement. If you're looking at distance, then you are looking at distance, it will be speed. Yeah. So just to recap, if this is speed, then here we are considering the distance covered, right? Then if here we are talking about velocity, then here we are considering the displacement.